With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Our question is, two vessels divided by a partition contain 1 mole of nitrogen and 2 moles of oxygen gas. If the partition is removed and gas is mixed isothermally, find the change in the entropy due to mixing, assuming initial and final pressure are same. So we over here are supposed to tell that what would be the change in entropy due to mixing. And what we have mixed, we have basically mixed 1 mole of nitrogen and 2 moles of oxygen, right? So initially they are saying that we had a vessel, right? We had two vessels in which in one case we had 1 mole of nitrogen, and in the second we have 2 moles of oxygen, right? And we had partition between them, and then what we did was we removed this partition and let the gases mix up. So now we have 1 mole of nitrogen and 2 mole of oxygen in the same container, right, without any partition. So we have to find delta S of mixing in this case. Now we're going to use our basic formula for delta S of mixing. Delta S of mixing is equal to minus R summation of Ni ln xi, right? So over here, what is this? This is universal gas constant. These are number of moles, and this is our mole fraction. So we're going to put the values over here now. What would happen? We need to basically sum up the product of this, right? Now this is what over here. First of all, we're gonna have number of moles of nitrogen and then ln mole fraction of nitrogen, right? And then we're gonna add, because we have to do summation, right, of this. Then the second case we have oxygen, so we're gonna have to put number of moles of oxygen, then ln mole fraction of oxygen over here, right? So now we're gonna put the value over here and find out delta S of mixing. So in this case we have minus R. Now number of moles of nitrogen that we have is 1 ln, then we have mole fraction. What is mole fraction? Mole fraction is basically number of moles of a particular substance that we are talking about divided by total number of moles, right? So in this case we have nitrogen that have 1 mole divided by total number of moles. Oxygen has 2 plus nitrogen has 1, so total number of mole are 3. Then plus we have number of moles of oxygen that are 2, and then ln mole fraction of oxygen, that means the number of moles of oxygen divided by total number of moles, that are 3. So now this would be what? This would be minus R, then we have 1 ln 3, right? So this would become automatically ln 1 by 3 plus we have 2 ln 2 by 3, right? So now how we can basically remove this negative sign? By inverting this, the denominator would go to numerator and the numerator would go to denominator, right? And hence we can remove this negative sign over here. So it would become R into ln 3 then plus 2 into ln 3 by 2, right? Now we're going to put the value. R is 8.314 in joules, right? Then we have ln 3. ln 3 is 1.1 plus 2 into ln 3 by 2. When we solve this, we get a value of 0.4, right? So we get 15.8 joule per Kelvin value, right? So this is our what? This is our delta S of mixing. So delta S of mixing that we are getting is 15.8 joule per Kelvin. So this is our answer to this question.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.